again, my video rudely cut on me, but as I was saying, this intersect function within the math tools is for the terrain. So I'll get to that. And then we have finally the collidable collision between two generic collidables, which basically gets the collision volume, and then this one intersects with this one. Pretty simple. So did all of those. I know the code is a little duplicated and sloppy, but that's something I want to fix over the summer because it is actually a very useful math tools class to have. I guess I could crunch terrain in here as well since I'm at it. So terrain obviously was a beast. It was a beast in graphics too, and it was a beast still in this. And I think it was the most complicated thing. It was one of the most complicated things that I wanted to rip my hair out with. So the terrain itself pretty much has, what it has is obstructive corners, which basically has the a min corner array and a max corner array, which hold all of the min and max corners of each cell in the terrain layout. So it also then has a vector of vectors of corners called corners. So I will show you how it is made, which is just a lot. It was pretty much everything that we took from Graphics 2, because it was ridiculous, but basically it created the terrain. I did it once, I've done it again. So it's pretty much just going through the image itself. It's obviously square, it's getting the sides, and then it's setting it's creating the mesh here, it's creating the winding, which is opposite of what it was in graphics, because the winding is obviously different with OpenGL, and it is then setting a Y value for, if you can determine like the height and stuff of it. And then it puts all of the min and max corners into a corner array. And it creates the plane, and then it's a graphics object, so it needs to have the plane, a texture, and a little shader and a texture. So this is the render AABB, which renders all squares on the terrain. So it'll go through each quarter array, and it will just basically increment these I and j values, just going from row to row, column to column, just going through every single one of them, and then just rendering all of those. And then I'll just have draws, and then this, I'll show you this in one minute. So to do all of this, to actually have collision with all of them, I had to create the collision test terrain. So this, again, just like the collision test pair, is a 4-step process. So what this does is it finds the min and max of the collidable's B-sphere on whatever object you are. It then will find all of the correct cells on the terrain to iterate through depending on where the collision B-sphere is colliding with, which I'll show you the iterator class for, and how, well, to get relevant iterator cells. It will then test the intersection between the terrain and the B-sphere, and then if it collides, it'll test the collidable's given volume with the AABBs of the terrain, which in my case, the terrain itself will be lighting up. So that terrain iterator, so pretty much, here it is, get relevant, cell iterator, it'll just basically see, will return trues, depending on the XY, the XZ and the mins, and it'll return a terrain iterator class, depending on if whatever one it's in, which I made an entirely its own iterator, custom iterator class, which basically is just the constructor is just setting variables. It has a get min, a get max, it has a begin, it has an end, an operator plus plus, it does not equal operator, so I had to use all of this to basically iterate and like get only the certain cells within the terrain. Let's see, what am I missing? Terrain data, blah, blah. Oh, yes, okay. So I also then had to create a completely its own terrain manager, I guess, the asset manager. So here we go. So it's like it's pretty much the same thing as all the other ones. Only difference is that it also has get a terrain itself, and then it returns a terrain model, which comes in very handy to get the model of the terrain and then just the terrain. So pretty much it's the same thing. I'm inserting things into a hash table, so there's a whole hash of trades, which is just one. And then the hash table node, simple. It's just like all of the other managers that I showed off before. So I showed you all of the methods. Train manager was that, and then, okay, I guess I could show you the collision. So okay, there we go. So I'll have to get out. So this is going to turn orange, at least for the B-sphere. Is going to turn orange. Well, it's going to turn orange and white, because it's just going through. So let's go over here so we can actually see. So if you could kind of see it, but it is obviously, it's touching whatever cells it'll move. So here's a good example. So obviously it's touching, the B-sphere is touching these three cells right here, but it is not touching that, but obviously the collidable group is. So if I go into these, obviously it's colliding, and the B-sphere is lighting up because this one is set to a B-sphere. Sorry, I keep on yawning. It's been a long day. So, yeah. It's going from each cell. It's not dipping in frames or any. And then I died. So,